In this video, we are going to discuss about some expected questions from the topic isomers. Okay, you might have seen this question in the sample question paper. So you have a 3-mark question is being asked from the topic isomers. So where you asked to find out the number of possible isomers for the formula C4H8 and to draw their electron dot structure for the branched one. Okay, so it's a sure question for 3-mark. So we'll see the possibilities, other possibilities from the topic isomers. So as you can see, you can expect some definitions like isomers, what are isomers, what is isomerism, some characteristics of isomers, okay, and then how many isomers are possible for a particular molecular formula, and draw all the possibilities, okay, draw the electron dot structure of a particular one. So all these questions are possible from this topic. So we'll discuss one by one, okay. So define isomers. You can expect like a definition for isomers, specifically structural isomers. Structural isomers, because you're studying only structural isomers. Okay, so define what are structural isomers or define structural isomers. Okay, so if you see these two molecules, okay, you can see like it contains 4 carbons. If you count the total hydrogen, this is 3 plus 2 plus 2 plus 3. So you have 10 hydrogen. So the first molecule, the molecular formula is C4H10, right? The second one also you can see like it's a 3 continuous carbon with a branch, that's a skeleton. Okay, so it's C4. Again, if you count the hydrogen, it's going to be like H10, C4H10. So both molecules, if I'm giving like 1 and 2, so both molecules, if you see the first molecule, the 4 carbons are connected linearly. In the second one, the 3 carbons are continuous, one as a branch. So obviously it's 2 different molecules, right? But they have same formula. Okay, so I can call 1 and 2 as structural isomers. Okay, so what are structural isomers? Molecules having same formula but different structure. Okay, so like that's what isomers is, molecule having same formula, different structures. Okay, so for a 1 mark, you can simply write this definition. Structural isomers means compounds having identical molecular formula but different structure. Same formula, different structure. So that's enough for a 1 mark. Along with this, they can also ask the properties of isomers, the characteristics of isomers. Okay, so we know isomers having same formula, different structure. That's a common point, comes under the definition of isomers. Other than that, what we can write? Okay, so we know in that C4H10 formula, okay, you can have 2 different arrangement, 2 different molecules possible, right? One with 4 continuous carbon, one with 3 continuous, and a branch. So it's totally different molecule, right? So if there are 2 different molecule, means their boiling point will be different. They have different boiling point. They have different melting point. The melting point will be different. Boiling point will be different. So either you can write they have different melting point or boiling point. Generally, this melting point, boiling point comes under physical properties. So generally, you can write instead of writing melting point is different, boiling point is different. You can generally write isomers having different physical properties, because the boiling point and melting point comes under physical properties. Okay, but if you know like this, both compounds containing only carbon-carbon single bonds, so they belong to the category alkane, right? So they're both are alkanes. So their chemical properties we cannot predict. Sometimes it'll be same, sometimes it'll be different. So we can write simply like they have same or different chemical properties. Chemical properties mainly the reactions undergone by these molecules. Okay, so that we cannot say they'll be different, but because both are alkane, they may have given like giving same reactions. Okay, so you can simply write like they have different physical property. The chemical property may or may not be same, so it can be same or different. So for a 2-mark question for definition and properties, you can got these points. Okay, hope it's clear. Now, another definition you can expect from this: what is isomerism? Okay, other than isomers, you can also expect what is isomerism. Okay, Now we know, like we saw that example where C4H10 can be arranged in two different ways. I'm just showing the skeleton, okay? I'm just showing the skeleton. I'm not showing the hydrogen. So it's two different molecule, right? But formula was C4H10. So with the same formula, you can have more than one compound, right? This is one compound. This is another possibility, the same formula. So this phenomena is called isomerism. The phenomena in which you can have different compounds with the same molecular formula. With the same formula, you can have multiple compounds. This phenomena in which isomers can exist. Isomers means with the same formula, different molecules can exist. This phenomena is called isomerism. So for a 1 mark, you can write this definition. Isomerism means it's a phenomena in which isomers exist. Means it's a phenomena in which you can have multiple compounds with the same formula. Okay, that can be written for like for a 1 mark. So you can expect that definition also. What are isomerism? What is isomerism? Okay. Then normally when we go to the sample papers, this is another possibility you can see. Okay, you will be given with a formula. Okay, and you may ask to find out how many isomers are possible with that formula. So here I'm discussing only alkane. Alkenes we'll discuss in some other time. Okay, so C3H8, we know all these are fit into the formula CnH2n plus 2. Okay, so the first alkane is given with 3 carbons. So you can arrange 3 carbons in 2 different ways, either like 3 continuous or you can 3 closed. But if you draw the closed one and if you see the number of hydrogens, it's going to be C3H6. So it's not this formula. So you can't have 2 possibilities. So only you can arrange the 3 carbons continuously with this formula. With this formula, only one possibility is there. C3H8 means only you can arrange 3 carbons with this number of 8 hydrogen only in one way. Okay, so only one isomer. Now C4H10. So C4H10 means you can arrange in 2 different ways, right? 4 carbon, either you can draw continuously as a straight chain or 3 continuous carbons and one not being part of the main chain, not continuous. Okay, so 2 possibilities. 2 possibilities. So for C4H10, you have 2 isomers. Okay, so there is no general formula to find out the number of possible isomers. So it's better to remember this C3H8 1 isomer, C4H10 2 isomer, means 2 structures are possible the same formula. Okay, now C5H12. So remember there are 3 possibilities. We'll draw it after some time. So just remember there are 3 possibilities with C5H12. With CH14, you have 5 possibilities. So 5 isomers for CH14. With 6 carbon, you can arrange in 5 different ways. So just remember C3H8 C4H10, you have 2 possibilities, C5H12 3, and CH14 5. Okay. So now they can ask like, okay, so this is one type. They can ask how many isomers are possible. So already C4H10, if you remember that, you can write it's 2. Now draw the electron dot structure of the branched chain isomer. I hope you know the concept of branch. A branch means which is not been part of the main chain. A main chain means the continuous carbon chain. Suppose if I'm starting to draw a line from this end, without taking my pen, how many carbons I can cover? If I go like this, I cannot cover this. So this is a branch. Okay. Suppose if I'm coming down like this, okay. If I'm coming down like this, I cannot cover this. So it's a branch. Okay. So branch means like the one which is not been part of the continuous chains. Okay. So in this question, you have been asked to draw the electron dot structure of the like branched one. So with C4H10, we know you have 2 possibilities. You can have 4 carbon continuous without any branch, and you can have like 3 carbons with a branch in the second position. Okay. So you are asked to draw the electron dot structure of this particular molecule. Okay. So for that, before drawing electron dot structure, make sure that you have drawn the normal structural formula, the complete structural formula with all the hydrogens. It will be very easy to convert into electron dot structure. So this is CH3, 3 valence is used. So CH Here only one valence is used, so 3 hydrogen, and the branched one also having 3 hydrogen. So if you have this, you can simply draw the electron dot structure. Already we discussed how to draw the electron dot structure. I'll just show only that. Okay, this example I'll show. So it's very clear that all the carbons are connected with a single bond. So just put one pair. So this is a CC bond, down also one CC bond. Now all hydrogen always forms a single bond. So you can put one pair between carbon and hydrogen. That will be 10 hydrogen, right? So the N carbon is connected with 3 hydrogen with a single bond. So one pair. Now like here also it's all single bonds. So all the shade area you need only one pair. So this is the electron dot structure for the branched one. Okay. So this is a question for 3 mark. Very important question. How many isomers are possible? Draw the possible isomers. If you ask to draw the possible isomers, you have to draw both these structures. Okay. The complete structural formula with hydrogen. This is just skeleton. Okay. A skeleton means just show how many arrangement is possible. So always you draw skeleton, then you satisfy, later you satisfy the hydrogen. So that will give better ideas. Okay. Clear. Now, like we know already, we discussed this is having 1 possibility, 2, 3, and 5. So already we discussed this one. So now you'll see how to draw 3 isomers for C5H12 and the 5 possibilities for CH40. Okay, we'll start with C5H12. Suppose the question is draw all the possible isomers of C5H12. So you have to draw all the 3 possibilities. So first you should remember there are 3 possibilities. 3 possibilities means there are 3 isomers, which means you can like arrange the 5 carbons in 3 different ways. How to do that? The first possibility is this. You can have 5 continuous carbon. 1, 2, 3, 4, 5. That's one possibility. Okay. I'm just drawing the skeleton first. Okay. Later we can satisfy with the second possibility. So you cannot have like 5 carbon anymore. Like, so next possibility is change the main chain, make it 4. So 4 continuous carbon. So you need one more, right? So it will come as a branch. Okay. So branch will be like in the second position. Okay. So this is one possibility. Some people will try to do like this. Okay. Thinking that if you draw like this, okay, don't think like the branch is the third position. Okay. So if you number like this, okay, 1, 2, 3, 4, you can see the first one, the branch is in the second carbon, right? So some people will think like this is 1, 2, 3, 4. The branch is the third carbon. It's a different possibility. No. Okay. Now the rule is that, okay, anyway, you're not studying the naming, but still remember the rule is that you should try the numbering from either side. So if I number from this side, 1, 2, 3, 4, it's still the branch is in the second position from the other side, right? So both are same. So it's not a new structure, it's the same thing. Okay. So with 4 carbon, you have only 1 possibilities with a branch in the second position. Okay. Clear. I hope it's clear. Now that's a like second possibility. Now third possibility, change the main chain again. Make it 3. Make it 3. Now the fourth and fifth as a branch. Okay, so this is the third possibility. So these are 3 possibilities with the formula C5H12. Now you can satisfy with hydrogens. You can draw hydrogens accordingly. So this will be 3 hydrogen in this. Okay, this will be 2. This also 2. This also 2. This will be 3. Okay. Similarly, you can other also you can satisfy with hydrogen. So will be I'm not showing the like I'm just writing the condensed formula. Okay. So for example, you write the expanded one. Okay. So 1 carbon, 1 bond is formed. So CH3. This is 1 carbon. So CH3. This is also terminal 1 CH3. All are in between. So this will be 1 hydrogen is in a 1, 2, 3. This is CH2. Okay. You draw the expanded structure. This is the condensed formula. Okay. Now here also there will be 3 hydrogen, 3 hydrogen, 3 hydrogen, 3 hydrogen. Okay, no hydrogen here because all the 4 valence is used. So these are the 3 possibilities with 5 carbon. So with C5H12, like how many isomers? 3 isomers. Okay, 5 carbon continuous, 4 and 1 branch, 3 and 2 branch. Okay. So sometimes they will ask to draw the structures. You can draw like this. Okay. Now, like the last one, C6H14, 6 carbon alkane. So there are 5, as I said, there are 5 possibilities. 5 possibilities. Okay. So like what are the 5 possibilities? I'm just drawing the skeleton. Okay, later you can satisfy the hydrogen. Okay. So 5 possibilities are like 6 carbon continuous. 1, 2, 3, 4, 5, 6. That's one possibility. Now change the main chain, make it 5. Now 5 continuous carbon. Okay, 1 branch. So here the branch is the second carbon, right? Now we have one more possibility is 5 carbon. 1, 2, 3, 4, 5. You can have the carbon, the branch can be in the third position. So here the branch is in the second carbon, here the branch is in the third carbon. Okay, so 3 possibilities. Now change the main chain. Okay, make it 4, the fourth possibility. Okay, so I'm making this main chain as 4 carbon. Now you need 2 more carbon, right? So 2 branch. One is in the second position, one is in third position. That's a fourth possibility. Now with 4 carbon, you have one more possibility. The branch can be in the same carbon. Okay, both can be in the second position. Okay, is there any other possibilities? Okay, there is no other possibilities. So you have only 5 possibilities. Okay, 5 isomers for C6H14. Okay, so it's only skeleton. You have to satisfy the hydrogen. I hope you know how to satisfy the hydrogen. Okay, so like make sure that there is 4 bonds around carbon. So here only 1 bond, so 3 hydrogen is required. Here 2 bonds is there around the carbon, so you need 2 hydrogen here. Here also 2, like, so you need 2 hydrogen here. Here also 2, so you need 2 hydrogen here. And this also 2 hydrogen. And this will be 3 hydrogen. Okay, so like that you satisfy the hydrogens. Okay, so these are some expected question from the topic isomers. Okay, hope you it will be helpful for you. So study what are isomers, isomerism, how many isomers are possible for a particular formula. We discussed only the alkane. Okay, we'll come up with the alkane some other time. Okay, now I hope it's helpful for you. So keep supporting. Okay, we'll come up with more video soon. Thank you so much.